The idea that a metallic structure weighing 200 tons, equivalent to about 130 compact cars, can rise smoothly to 30,000 feet and cross oceans at nearly 1,000 kilometers per hour seems to the common observer to defy the laws of reality. However, what begins as a raw mass of ore and industrial alloys is about to be sculpted, tested, and refined until it becomes the pinnacle of modern engineering, a long-range luxury jet. This is the chronicle of its creation, a process where the brute force of the foundry meets the delicacy of microtechnology. The metallic dawn, the alchemy of alloys. It all comes to life in the hostile environment of high-precision foundries. Aluminum, in its pure state, is far too malleable for aerospace demands. Therefore, the process begins with a rigorous chemical recipe. In gigantic crucibles, aluminum is melted at temperatures exceeding 600 degrees Celsius and mixed with elements such as zinc, magnesium, and copper. The goal is to create 7075 aluminum or similar alloys, which possess the density of aluminum, but the mechanical strength of certain types of steel. In this phase, the liquid metal is poured into molds that will give rise to the primary ingots. The secret of a luxury aircraft's integrity is born here, in controlled cooling. Metallurgical engineers monitor the solidification degree by degree. If the metal cools unevenly, invisible internal stresses arise that could cause structural disintegration under atmospheric pressure. It is a science of patience and thermal precision that ensures the flesh of the giant is flawless. Digital sculpture, the mastery of CNCs. With the solid blocks ready, we enter the era of ultra-precision machining. CNC, computer numerical control, machines the size of houses take over. Equipped with tungsten carbide drills spinning at tens of thousands of revolutions per minute, they begin to excavate the raw aluminum. Imagine a 10-ton block of metal that, after 24 hours of uninterrupted machining, transforms into a wing rib weighing only 500 kilograms. More than 90% of the material is removed and recycled, leaving behind an intricate structure of supports and cavities designed by algorithms to withstand immense aerodynamic loads. Every curve, every millimeter of thickness is calculated so that the part is as light as possible without ever compromising safety. For a luxury jet, this lightness translates into greater range and comfort, allowing the aircraft to fly from São Paulo to Dubai, non-stop. The backbone, spars, and heat treatment. While the fuselage takes shape, the backbone of the plane is prepared. Spars are colossal beams that run the entire length of the wings and connect to the center of the aircraft. They are what prevent the wings from folding or breaking during severe turbulence. These parts undergo a process called artificial aging in heat treatment furnaces, where the metal is heated to specific temperatures to rearrange its molecular structure, increasing its hardness. After the heat comes the ultrasound test. Like a medical exam, probes traverse every inch of the metal looking for micro air bubbles or internal fissures. If a single imperfection is detected, the million-dollar part is discarded. In luxury aviation, perfection is not a goal. It is the minimum requirement. The symphony of rivets and robotic assembly. The assembly of the fuselage is a spectacle of coordination. Unlike an automobile chassis, which is welded, a 200-ton aircraft is held together by millions of rivets. Welding creates a structure that is too rigid and could crack under constant vibration and pressurization cycles. The effect of the cabin inflating and deflating according to altitude. Rivets, on the other hand, offer the microscopic flexibility necessary for the long life of the aircraft. High-precision robotic arms drill the aluminum skin and install the rivets with constant, exact pressure. In a luxury jet, the surface must be so smooth that the airflow suffers not the slightest interference. Each rivet is leveled and inspected by high-definition cameras. The alignment of the large sections, front, center, and rear, is done using laser guides that ensure that in a 60-meter-long structure, the alignment error is less than the thickness of a credit card. The wings. Engineering of flexibility and power. The wings of a luxury jet are true masterpieces. In addition to generating lift, They serve as fuel tanks and supports for the engines. The internal design is a complex honeycomb of ribs and chemical sealants that prevent leaks under extreme conditions. The most impressive test is the static bending test. The wing is pulled by hydraulic cables upward until it forms an arc that defies logic. It must be able to withstand up to 150% of the maximum expected load in flight without suffering permanent deformation. This elasticity is what ensures that even in the worst turbulence, passengers in the luxury cabin feel only a slight sway, while the wings work to absorb the energy of the atmospheric impact. The heart of the Titan, jet turbines. No giant wakes up without its heart. Jet engines are the most efficient and reliable thermal machines ever built. Inside these turbines, the blades spin in an environment where the temperature exceeds the melting point of the metal they are made of. How is this possible? Through microscopic internal cooling channels and ceramic coatings that create a bubble of cool air around the blade. Each engine is mounted on pylons under the wings. These supports are designed with structural fuses. In a catastrophic failure or extreme impact scenario, the engine is designed to detach from the wing without damaging the fuel tanks, ensuring that the rest of the aircraft remains intact. The nervous system, hydraulics, and fly-by-wire avionics. A 200-ton luxury jet has no physical cables connecting the yoke to the control surfaces. Instead, it uses the fly-by-wire system. The pilot's commands are converted into bits and processed by 3 independent computers that vote among themselves to ensure correct execution. The hydraulic system, operating at 3,000 psi of pressure, acts as the muscles, moving tons of metal with the precision of a Swiss watch. Miles of silver-coated copper wiring and fiber optics run through the aircraft, connecting sensors that monitor everything from tire pressure to cabin air quality. The internal sanctuary. Luxury meets safety. While the exterior is pure strength, the interior is a sanctuary of technology. In a jet of this category, acoustic insulation is paramount. Layers of composite materials and technical fabrics are installed to ensure that engine noise is only a distant whisper. Pressurization is adjusted to simulate lower altitudes, which reduces fatigue and jet lag for passengers. Every seat, every exotic wood panel, and every entertainment system is tested to withstand impacts of up to 16 G, ensuring that luxury never compromises survival. The skin of the giant, painting and finishing. Before flying, the aircraft receives its final skin. The paint is not just aesthetic. It protects the aluminum against galvanic corrosion, intense UV radiation, and thermal variations ranging from plus 150 degrees Celsius on the asphalt to 55 degrees Celsius in the stratosphere. Hundreds of liters of electrostatic paint are used, applied in layers so thin that the total weight of the paint is strictly controlled, so as not to affect the aircraft's center of gravity. Ground baptism and the conquest of the blue. The final stage is the total integration test. With the aircraft static, the engines are pushed to maximum power, the so-called full thrust, making the entire structure vibrate while carbon brakes hold the 200 tons in place. The landing gear is cycled repeatedly in test hangars to ensure that retraction is perfect. Finally, takeoff day arrives. Test pilots take the cockpit, surrounded by advanced telemetry. The giant accelerates, the engines roar, and at a decision speed calculated in thousandths of a second, the nose rises. The moment the wheels leave the ground is the validation of millions of hours of work, thousands of parts, and an unwavering commitment to precision. The raw aluminum is now a master of the skies, ready to serve as an office in the clouds or a luxury refuge around the globe. So, were you able to follow this incredible journey from raw aluminum to the skies? Impressive, isn't it? Every detail, every rivet, every system working in perfect harmony to defy gravity and transport hundreds of people with absolute safety. If you were fascinated by the behind the scenes of this extraordinary engineering, I have a special request for you. Leave a like on this video. It really helps the channel grow and bring more amazing content like this. Comment below. What was the most impressive part for you? Was it the microscopic precision machining? The wing bending tests? Or that exciting moment of takeoff? I want to know your opinion. And most importantly, if you're not yet subscribed to the Secrets of the Extraordinary World channel, go there and hit that subscribe button. Activate the notification bell so you don't miss any new videos. Every week I bring you exclusive content revealing the secrets behind the greatest wonders of engineering, technology, and innovation in our world. Share this video with that friend who is passionate about aviation, engineering, or who simply loves learning new and fascinating things. See you in the next video, where we will unveil more extraordinary secrets of this incredible world. Until then, stay curious. Secrets of the Extraordinary World. Unveiling the mysteries of modern engineering.
Check out this channel. The making of our plane is here.
Wow! Secrets of the Extraordinary World? Subscribing and liking right now.